Hey everyone, this is back from week 4, day 7. We talked about a little bit about course materials, check. We talked about the softball baseball problem, check. Models and design, can talk about that the next time. Practice 3, check. And we did the quiz. Talked about data, user, enter data, and use it. How we interact with that data, some algorithm, how we use it. So much of the course, as we talk about it, wraps around this whole idea of having data and the best way to use the data in the world. Okay, so that took care of Wednesday of that week. And Monday of this week. So now we change color here. Now we're on week 5, day 8. So we have we went over the assignments, some questions, and you need to check my comments. Database design, we talked about some terms, and we worked to try to understanding. We worked on practice 4, which was students, they created a table to intermix with the countries. Okay, we did a good review of concepts, and we just are beginning to talk about some relational concepts. YSQL at the command line, you better learn the concepts, and we can use programming languages to design it. How do we learn? We learn a lot of it by doing. We had some online work, and we have these assignments, and we have the practices in class. Every time you do work in that, make sure you include the SQL statement, the results, and how many records at the end. So you have the statement, you have the results, and then that little summary down below. We're going to come back to top-down design. I reviewed how to access remotely. Oops, let me get rid of that. The username in here, at here. But before you can SSH, you need to connect to 85. So you connect to work server 2, then that allows you to connect to work server 1. Okay. In here, we talked about data. It could be stored locally, local server, in the fog, in the cloud. And then from that data, we can have databases or data lakes. Data lakes are like a more comprehensive storing everything. A database is what we're working on, what we're learning about. Then we have software that takes the data, makes information out of it. Could be a program, could be an app. The app could stand alone in your phone, the app could run in a browser, or we can have something like Canvas. Canvas, an app, or Canvas can run in a browser. Now if we look at this bigger picture, up here we have users. So we have this group, and they have different views of this data. And how do we give them the views we want? We can use the web, we can use some user interface, user experience. And we can develop, in order to develop our database, typically we start with a conceptual view, and we build these entities. The idea of these are the things we want to represent. I used an example of Airbnb. Airbnb said, well, customers, okay, people who want to rent space, then we have the people who are going to rent the space, and then our little financial entity in between. So you think of conceptually what you want to do. Then you build logical data models. I draw tables like this. You can draw it different ways. You can list the entity and then list the fields or attributes underneath it. And we're doing a lot of work now dealing with that coming up. Then we can create the physical data model, where we actually build the tables. We create the tables and the fields within there and build the relationships between the tables. Maybe this relates to this over here. And how we build that, we use a relational database management system. We're using MySQL. And this then writes the data to the hard drive. It actually stores it somewhere. Okay. So in a way, we have this user who's able to go through all of this, get the data they want up here without having to know anything that happens in between. So here's kind of a look at the big picture. We have our data just stored somehow, and then in our course we're using a database, MySQL, to allow us to write queries on the data, create tables, update the data, delete the data, and so forth. And so everything in between here, then everything that happens between here, software makes that happen. Okay, software makes that happen. So we can take the data, create information. Now the whole next chapter we're going to talk about are relationships. How does, if we take a primary key to another table in which it's a foreign key, how do we build those relationships? So if we're going to use data from one table in another table, how can we make sure that this data here matches this data over here? How can we do referential integrity between our tables? So that's our next step, entity relationship diagrams. So here, this was an example from class today. I gave an example here to where we created the table and started inserting information into the table. This was from the practice today. Or the practice, not actually today, the other day, on Monday. So you can look at that. Now one thing we didn't for this right here, we did not reference that key in the other table. We haven't talked about that much yet, but we will next week on Monday. A couple more things to go over. Two different approaches to whether you're talking about designing software or designing information systems. We can do a top-down, or often called a waterfall approach, or we can do a bottom-up, or maybe something that's more generic called agile, in which we create sprints. There are lots of information on both of these. If you want to look it up, I'll just do a little preview. So in the top-down analysis, we do analysis, get feedback, and you typically are careful about moving to the next stage until you're sure you've done all the analysis. Then you work on the design, get feedback, and you make sure you have your design done before you start developing. Then you implement. Once you've developed and tested and so forth, and then you implement, and then you figure out how you're going to implement, how you're going to put in the new system, and then the system gets analyzed to see if it's producing the results it should. Example here could be building a house. You really can't dig the basement until you know for sure what you're going to do. So the analysis would be, can you afford it, how many bedrooms, and so forth. It's kind of like the conceptual view of a database. Then you start creating design. This would be the logical part of a database, where now you're putting all these parts together. Develop it, you start building the tables and linking everything together, and then implementation. If you're building a house, you can't start pouring the foundation until you have the design done. So for a house, a waterfall works pretty good. For a database, you might want to try to do it bottom up, in which you get part of the design done, and then you try to implement part of it right away. So more or less you create, we'll use the term, prototype. You create a prototype and then you test it and see how that works. Then you make adjustments to it. Okay, so you kind of go through these same phases here, but you go through them quickly, get a prototype, and then you reiterate that. So it's kind of like bottom up. You build while you design, and so forth. This is where we're finishing up. So I submitted, let me clean this up here a little bit. This is my solutions to the terms in the outline. A couple different places you can get whiteboard reviews. We need to finish up this discussion. We did practice 4. Some solutions. There's the solutions to the quiz. You need to look at this review, and then on Wednesday we'll take the exam, and then I'll turn the solutions on as people are finishing up the exam. And that is it.